In this short video, our team will be presenting the fault analysis of a conceptual design of the McMaster University microgrid.
My name is Shehnaz Kausar.
My name is Melvin Mangu.
And my name is Serena Malik.
The scope of the project is to perform simulation and testing of the feeder line protection system. To obtain the project scope, the following steps were taken. Simulate a three-phase fault using the EMTP model at the McMaster feeder line, analyzing fault current using scope view and Syncrowave, generating and uploading the COMTRADE data file, and performing SEL 751 relay testing using SEL 5401. EMTP is an excellent simulation software for generating the fault waveform. Syncrowave is more likely to display the fault and also plot the waveform in the time and phasor domain for the fault analysis. The project is to evaluate the relay setting using the simulated fault current. I will now explain the EMTP model for the McMaster feeder line.
For our fault analysis, we created this simplified design with an AC source voltage device rated at 115 kilovolts, which is then connected to a step-down three-phase delta Y grounded transformer, which steps down the voltage to 13.8 kilovolts for distribution purposes. In addition, there are also two synchronous independent generators of 16 megawatts and 10 megawatts, which are connected to their bus respectively. The secondary side of the transformer is connected to the feeder line, which is connected to the McMaster University Hospital. The design also consists of several 5051 relays, one located after the secondary side of the transformer for the protection of the upstream equipment, and the other relay just before the load. A fault was also created with a time closing of 1 millisecond and a time opening of 2000 milliseconds, which can be seen here. Finally, 3 control switches were used to get better control on the generation in case of a power loss or voltage swell from switching from one source to another. For the simulation, the main time step is set to 1000 milliseconds and the simulation time to 10 seconds.
In order to run this model, we will go to the Simulate tab and Simulation Options. Make sure the steady state condition is checked, the main time step is set to 1000 microseconds and the simulation time to 10 seconds. Then in the Output tab, make sure the Save Intermediate Time Points is not checked in order to avoid extra data for the fault current. Click OK and run the simulation. Once the simulation is complete, go to the View Scopes with Scope View button to see the results. From the signal type, select Switch Current and select the currents IA, IB, and IC. You can change the page numbers here if needed. Click Start to run the simulation. On the graph, we can see that the fault appears at 1 second and the fault current is much larger than the load current. To generate the COMTRADE file, click Export and make sure the file type is .cfg. Select from the current page and provide a unique name to the file before clicking Export. The file will generate into a .cfg and .dat format. When we open the file with the notepad, we can see all the information about the fault data. We can see the IA, IB, and IC frequency and sampling rate. When we open the .dat file with notepad, we can see that it contains all the points of the fault data. Now we will use SEL Syncrowave to analyze the fault data we have generated. After uploading the COMTRADE data to the software, we can see the phasor representation of the three-phase fault. We can add the currents IA, IB, and IC to the phasor diagram. As we move the cursor, we can see the three-phase current is displaced by 120 degrees and the fault is 45 kiloamps. Melvin will now explain how to upload this file onto the relay.
I would like to go into how to upload the COMTRADE file to the SEL AMS, as well as how to monitor the status of the SEL 751A relay using the SEL QuickSet. To upload the COMTRADE file, we are going to use the SEL 5401. We are first going to connect the SEL 5401 to the SEL 751A relay, which is a feeder line relay. Once the connection is established, we are going to use this tab here to upload our COMTRADE file. We will first upload the COMTRADE file to the IA channel and making sure that the COMTRADE file is set to IA. The scale factor is set to 120 since we've been using a scale factor of 120 throughout the project. The steps are repeated for channel IB and IC. Once the COMTRADE file has been uploaded to channels IA, IB, and IC, we are going to change the time cycle to 65 cycles since the fault current occurs after 60 cycles in our COMTRADE file. Then, we are going to open SEL QuickSet, where we will use the HMI window to view the status of this SEL 751A relay. As we can see, the QuickSet is connected to the SEL 751A relay, and the relay is currently in service. Now, we are going to download and run our COMTRADE file. As we can see, the COMTRADE file is getting downloaded to the AMS. Once the downloading process is over, the AMS will play the COMTRADE file, which will trip the SEL 71A, as we can see from the HMI window. Now, I would like to hand over to Shehnaz for the conclusion.
Thank you, Melvin. The project is to simulate the three-phase overcurrent fault and generate the COMTRADE file for the fault analysis and uploading on relay. The overcurrent fault analysis is using by scope view and synchrowave. It is observed that the fault current is much higher than the load current. The cell 5401 is uploaded the overcurrent fault on the 751 relay. Relay has setting for tripping time and time dial setting. When relay sees the overcurrent fault in the transmission line, it tripped to clear the fault. Overcurrent caused overheating in the transmission line and leads to short circuit. The project is successfully completed and the scope of the project is obtained. Special thanks to the following people who helped us in completing our project. Thank you so much for watching the video. If you have any question, please contact us by email or chat with us by the link provided.